A farmer wants to build two neighboring equal-sized rectangular enclosure for his sheep and goats, as figure shown below. If the length of fencing he has is 1,200 feet, what is the maximum possible area for the enclosure? And also, what is the dimension of each rectangular enclosure? Okay, so let's just assign some values here. We're just going to say this is x, and we call these lengths as y. Now the reason I want these lengths is because this rectangle will now have the area x times y, and this will also have x times y, so that will be the total area. So A is equal to 2xy. And since we're trying to maximize this, we're trying to find the maximum possible area, this will be our target. Now what's the constraint? Well, the constraint is that he only has 1,200 feet of fencing. So see, this length is also x, that length is also x. So the total amount of fencing will be x plus x plus x plus x and y plus y plus y, right? So you have a total of 4x and 3y, and these can only be adding up to 1,200. Okay, and since this is an equation, that's the constraint, 2xy is the target, and that's it. That's our setup here. Okay, the setup is under the constraint that 4x plus 3y is 1,200. What's the maximum value of the target? And as usual, we solve this for y or x. Sometimes solving for x might be a simpler equation. But here it looks like it's the same. So if solving for y and solving for x is about the same, I choose to just solve for y so that the resulting function is a function of x. Okay, so first subtract 4x both sides. Divide by 3. So you have 1,200 divided by 3 and 4x divided by 3, which is like 400 minus 4/3 x. Now I have solved for y. You plug that into the target function, and here is the target function as a function of x now. 2x times 400 minus 4/3x. Let's simplify this by distribution. So that's 800x, and then 2 times 4 is 8, so 8/3 x squared. Okay, now what do? We differentiate that because we want to find the critical number, and once you find the critical number, we can use the first derivative test to indeed see that the function a will be maximized for the critical number. Okay, so a prime is equal to 800 minus x squared differentiates to 2x. 2x times 8 will be 16x over 3. And set that equal to 0 because I need the critical number. Right? So I'm going to move this to the other side, and you get 800 equals to 16/3x. Okay, and then, okay, I'll need a new page. Right, so what we get is, so we're here 800 minus 16/3x equals to 0, which gives you 800 equals to 16/3x. So you want to divide both sides by 16/3. But dividing is same thing as multiplying the reciprocal, right? So 800 times 3/16, that's the reciprocal of 16/3. And on the right side, this is going to get canceled. So these are going to get canceled, and we get x equals to 800 times 3/16. I see that both 800 and 16 are divisible by 8, so it's 100/2. But again, 100 divided by 2 is 50, so I get the value of x equals to 50 times 3, which is 150. Okay, So that's my critical number. And it's very likely that 150 is going to give us the maximum, but let's just make sure indeed that's the case by choosing a number before. So we need to pick test points to make sure that f prime tells us that the function is increasing before and decreasing after. So let's pick 0 as a test value, my favorite test value. And a simple number after 150 is, I would say it's 200, okay? So I picked these test values, and let's go back to see what the prime was. 800 minus 16x over 3 is our a prime. You know what? Seeing that I have to divide by 3, I want to change my test value to 300. That's easier, okay? So I'll choose this to be 300, okay? And remember, a prime is 800 minus 16 over 3x. So a prime valued at 0 is 800, which is positive. So we know that a prime is positive here. And then a prime at 300 would be 800 minus 16 over 3 times 300. 300 cancels, and you get 800 minus 1600. So that's definitely less than 0, right? So it's negative. So we indeed see that a would be increasing before and decreasing after, making this as the maximum, okay? So when x is 150, we get the maximum. It gives us maximum by first derivative test. Okay. All right, so let's now actually figure out what y is. Remember, we had 3y plus 4x equals to 1200. And when you plug in 150, we get 3 times y plus 4 times 150 is 600. So subtracting 600 both sides, you get 3y equals to 600, and dividing by 3, you get y equals to 400. So, no, actually, not 400, 200. So now we have a dimension where you get the maximum, and the area in this case would be 2 times x times y. Remember, a was 2xy, right? So a is 2 times 150 times 200. 150 times 2 is 300. 300 times 200 is 60,000. And this is square feet. So that's the max. So this is our answer. And the dimension of one rectangle is x times y, right? So that's dimension would be 150 feet by 200 feet. Okay? So that's the full answer for this question.